Hi class, thanks for joining me today. We'll be learning how to solve systems of linear equations in two variables with the substitution method. By learning how to solve systems of linear equations, you will build a foundation for solving complex problems. We have been working with equations of the form ax plus by equals c. A system of linear equations, or a linear system, is two equations of the form ax plus by equals c. A solution of a system of linear equations is an ordered pair that satisfies both equations in the system. Here's an example. X plus y equals 7 and x minus y equals -1 is an example of a system. The ordered pair 3, 4 is a solution of this system because when you substitute 3 in for x and 4 in for y, you get 3 plus 4, which does equal 7, and 3 minus 4, which does equal -1. How to determine whether ordered pairs are solutions of a system. For an ordered pair to be a solution of a system, it must satisfy both equations in the system. That is, it must make both equations true. Here's an example. X plus 2y equals -7 and 2x minus 3y equals 0. Determine if 1, -4 is a solution of the system. First, write down the problem. You want to substitute 1 and -4 in for x and y of each equations. Start with the first equation, x plus 2y equals -7. Substitute 1 for x and -4 for y to get 1 plus 2 times -4 equals -7. Multiply to get 1 minus 8 equals -7. Subtract 8 from 1 to get -7. -7 does equal -7, so this is true. Now for the second equation. Substitute 1 for x and 4 for y. Multiply to get 2 plus 12 equals 0. Add to get 14 equals 0. 14 does not equal 0, so this is false. Because the ordered pair does not satisfy both equations, 1, -4 is not a solution. Checkpoint number 1. Consider the system 2x plus 5y equals -24, 3x minus 5y equals 14. Pause the video and determine if each ordered pair is a solution of the system. Once you have found your answers, continue the video and see if you are correct. The answers are A, not a solution, and B, solution. Solving a system by substitution. There are 5 steps to solve a system by substitution. 1. Solve either of the equations for one variable in terms of the other. If one of the equations is already in this form, you can skip this step. 2. Substitute the expression found in step 1 into the other equation. This will result in an equation in one variable. 3. Solve the equation containing one variable. 4. Back substitute the value found in step 3 into one of the original equations. Simplify and find the value of the remaining variable. 5. Check the proposed solution in both of the system's given equations. Example. Given the system y equals -2x plus 4, 7x minus 2y equals 3, find the solution. Start by writing down the system. The first step is to solve either of the equations for one variable in terms of the other. The first equation is already in terms of one variable, so this step is already done. Y equals -2x plus 4. Step 2. Substitute the expression found in step 1 into the other equation. Write down the other equation, 7x minus 2y equals 3. You know that y equals -2x plus 4, so substitute -2x plus 4 in for y. Step 3 is to solve the equation containing one variable. Distribute the 2. Combine your like terms to get 11x equals 11. Divide both sides by 11 to get x equals 1. Now step 4 is to back substitute the value you found in step 3 into one of the original equations. Use the original equation y equals -2x plus 4. You found that x equals 1, so substitute 1 in for x. Simplify to get y equals -2 plus 4. Add to get y equals 2. Now you have found your x value and your y value. So the solution is the ordered pair 1, 2. Step 5 is to check the proposed solution in both of the system's given equations. Write down the original system in the order pair you found. Start with the first equation. Substitute 1 for x and 2 for y to get 2 equals negative 2 times 1 plus 4. Simplify to get 2 equals 2. This is true. Now for the second equation. Substitute 1 for x and 2 for y. Simplify to get 3 equals 3. This is true, so your solution that you found is correct. Checkpoint number 2. Solve the system by the substitution method. Pause the video and see if you can get the correct answer. Then continue to see if your answer is right. The solution is the order pair 6, 11. Here's another example. Solve the system 5x plus 2y equals 1, x minus 3y equals 7. First, write down the system. Step 1. You need to solve either of the equations for one of the variables. Choose the second equation to solve for x so that you can avoid fractions. X equals 7 plus 3y. Step 2. Substitute the expression you found in step 1 into the other equation. First, write down the other equation, 5x plus 2y equals 1. You found that x equals 7 plus 3y. Substitute 7 plus 3y in for x. Step 3. Solve the equation containing one variable. Distribute the 5, then combine like terms to get 17y equals negative 34. Divide both sides by 17 to get y equals negative 2. Now for step 4. Back substitute the value you found in step 3 into one of the original equations. X equals 7 plus 3y. You found that y equals negative 2, so substitute negative 2 in for y. Simplify to get x equals 1. You found that y equals negative 2 and x equals 1. So the solution is 1, negative 2. Step 5 is to check the proposed solution in both of the system's given equations. I'm not going to go through step 5 step by step, but here is the work in case you need it. Checkpoint number 3. Solve the system by the substitution method. Pause the video and see if you can solve the system. Then continue the video to see if you got the correct answer. The solution is negative 2, 5. So how'd you do? If you struggled, go back through the video and try the examples once more. Go through them slowly and work step by step to make sure you can avoid mistakes. Once you feel comfortable with all the material, complete the attached worksheet before class tomorrow. When we get to class tomorrow, we'll continue working with solving systems by the substitution method. Have a great night.